Welcome to our deep dive into the importance of our world's oceans, titled The Role of Oceans in Regulating Earth's Climate. Oceans, covering about 70% of the Earth's surface, play a critical role in maintaining our planet's climate balance. As we journey under the sea, we'll explore how seas and oceans moderate global temperatures, influence weather patterns, and support life on Earth. From heat absorption to ocean currents and storms, join us as we unlock the mysteries below the surface. Let's plunge in and discover how these vast bodies of water help keep our planet habitable. 1. Heat absorption. Oceans play a crucial role in absorbing excess heat generated by greenhouse gas emissions. In fact, they take in over 90% of this heat, acting as a massive buffer against global warming. This tremendous capacity acts much like a thermostat, keeping Earth's temperature in check. The heat absorption capability of the oceans prevents the release of larger amounts of energy into the atmosphere, which could potentially lead to more extreme weather events. By absorbing heat, oceans slow the rate at which the atmosphere would otherwise heat up. This natural process underscores the importance of oceans in maintaining the delicate balance of our planet's climate. However, the warming of ocean waters can have secondary effects, impacting marine life and weather patterns across the globe. 2. Carbon sink. In addition to absorbing excess heat, oceans function as a vital carbon sink, storing approximately 25% of human-caused CO2 emissions annually. This process significantly helps in reducing the amount of carbon dioxide present in the atmosphere. When CO2 is absorbed by ocean water, it undergoes a series of chemical reactions and is stored in the form of carbonates. This ability to store carbon slows the pace at which atmospheric CO2 levels rise, providing a crucial service in mitigating climate change. However, the continuous uptake of carbon dioxide affects the ocean's chemistry, leading to acidification. Nevertheless, without this carbon sequestration ability, our planet's atmosphere would contain far more greenhouse gases, accelerating global warming at an unprecedented rate. 3. Thermohaline circulation. The thermohaline circulation, often referred to as the global conveyor belt, is a vast oceanic system driven by differences in temperature and salinity. It plays an essential role in redistributing heat across the planet. This circulation ensures a balance, moving warm water from the equator to the poles and returning cold water back to the equator. By doing so, it influences regional climates, with areas like Europe experiencing milder climates despite their northern latitudes. The variations of temperature and salinity with depth create currents that are crucial to maintaining this balance. Disruptions to this system, however, can have widespread effects, altering weather patterns and impacting marine ecosystems. 4. Evaporation and rainfall. Evaporation from ocean surfaces is a major component of the Earth's water cycle, acting as the primary source of water vapor for the atmosphere. This water vapor is essential for cloud formation and precipitation. As such, oceans are directly connected to weather patterns, influencing everything from local rainfall to larger climate systems. The process of evaporation releases latent heat, helping to transport energy and moisture across the globe. The relationship between oceans and evaporation underscores the intricate connections between marine and atmospheric systems. Without this critical interaction, our climate and water systems would be drastically altered, affecting everything from agriculture to everyday weather forecasts. 5. Reflection and absorption. The ocean's surface plays a significant role in Earth's energy balance by reflecting and absorbing solar radiation. The reflection of sunlight, known as albedo, affects how much energy is retained in the Earth's climate system. Oceans reflect a portion of this incoming radiation, helping to cool the planet. The energy that is absorbed warms the water, influencing surface temperatures and, consequently, climate patterns. This balance between reflection and absorption stabilizes the Earth's climate over time. Changes in this balance, such as increased absorption due to warming, can have profound effects on global temperatures. The ocean's ability to moderate and distribute solar energy is thus central to the stability of the global climate. 6. Storage of solar energy. With a high specific heat capacity, water can store considerable amounts of solar energy. This characteristic of ocean water moderates temperature fluctuations between day and night, as well as across seasons. It ensures that temperatures do not vary too drastically, creating more stable environments, both on land and in marine settings. Consequently, the oceans act as a buffer against extreme temperature changes, promoting stability in the Earth's climate system. This capacity to store energy also allows for more gradual transitions between seasonal climates, enhancing the resilience of ecosystems and human societies. Ocean waters are therefore instrumental in maintaining seasonal rhythms that many species, including humans, have adapted to over thousands of years. 7. Climate feedback loops. Ocean warming can also trigger climate feedback loops, which either amplify or dampen climate processes. One such mechanism is reduced ice cover, which in turn reduces the Earth's albedo, or reflectivity. When ice melts, darker ocean water is exposed and absorbs more heat, contributing further to warming. This feedback loop can accelerate the rate of global warming, emphasizing the interconnected nature of climate systems. The interactions between oceanic processes and climate feedback loops underscore the complexity of predicting climate change impacts. By understanding these links, scientists aim to develop models that better forecast future climate scenarios. Each element of this feedback illustrates the cascading effects of ocean warming on global climate. 8. Sea ice and albedo. Sea ice is a vital component of the Earth's climate system, reflecting a significant portion of sunlight back into space. This high albedo effect helps keep polar regions cooler. However, as temperatures rise, more sea ice melts, leading to the exposure of darker ocean water that absorbs more heat. This shift accelerates warming, creating further sea ice loss in a reinforcing loop. Beyond albedo effects, sea ice also plays a role in regulating global ocean circulation and providing habitat for numerous species. The decline in sea ice not only has immediate regional impacts, but also long-term global consequences, affecting climate patterns and sea levels. 9. Ocean currents and storms. Ocean currents, particularly warm currents like the Gulf Stream, fuel weather phenomena such as tropical storms and hurricanes. These storms are vital components of the Earth's heat distribution, transferring heat energy from equatorial regions to higher latitudes. The interaction between ocean currents and atmosphere helps regulate climate and weather patterns, impacting coastal climates significantly. However, warmer and more energized waters can lead to more intense storms, with profound implications for coastal communities. Understanding the dynamics between currents and storms is crucial for forecasting storm behavior and preparing for their impacts. 10. Acidification and ecosystems. As oceans absorb more CO2, they become more acidic, posing threats to marine ecosystems. This acidification affects the ability of organisms, such as corals and shellfish, to build their calcium carbonate structures. Changes in these ecosystems can disrupt carbon cycling and food chains, with ripple effects on global biodiversity. The interconnected nature of ocean systems means that alterations in chemical composition can translate to broader impacts on climate and marine life. Protection and management of these ecosystems are essential for maintaining their role in regulating Earth's climate. This delicate balance highlights the intricate connections between oceans, climate, and life on Earth.